Hi everyone. Today we're going to learn about the mole. So before we get into what the mole is, we're just going to quickly revisit how do we measure different items or substances in chemistry. Now we can measure the mass of a substance, its volume, or the quantity of it, pretty much how many pieces there are. If we measure mass, we are going to use grams. If we're measuring volume, we would use liters. Now if we're counting how many pieces of a substance there are in chemistry, we are going to use what's called the mole. The moles are a way of just representing how many of a certain substance or an item are present in a sample. So the mole might call to mind this small little cute furry animal, but in chemistry we don't talk about this kind of mole, right? We talk about a different type of mole, a quantity here. So what exactly is the mole? The mole is a counting number. Think of it like a dozen, except where a dozen represents 12, the mole represents its own unique number. Now, the mole also goes by the name Avogadro's number. 1 mole is equivalent to having 6.02 times 10 to the 23 items or pieces of something. Just like how a dozen will represent 12, 1 mole will represent this number, 6.02 times 10 to the power of 23. Now, a dozen's more familiar because in our everyday lives, we're constantly dealing with dozens of things. We don't necessarily ever work with a number this large, right? A number that's got 21 zeros at the end of it. But when we're dealing with chemistry, we are working with atoms and molecules and all these tiny little particles. So even a small sample will have an enormous amount of particles in there. And so that's why the mole represents such a large number. Now, some other words that kind of call to mind what the mole is or are similar to it would be like a pair, a dozen, gross, ream, right? All of these words are really representing a quantity. Whereas a pair represents 2, dozen, 12, right? A gross, 144, and a ream, 500. The mole is no different, right? The mole just represents a number. But this is just a less common number, and so that's really the biggest challenge for students who are really first learning about the mole. Because when in your life do you really ever use this number? Well, outside of chemistry, you really don't. But the mole is just like these other terms. It just means a number. Okay, but that number for us in chemistry is 6.02 times 10 to the 23. So why exactly do we even need the mole? Well, we use the mole in order to be able to compare between elements on the periodic table. When we're dealing with different substances, we can't compare their masses together, right? Consider having a pound of bricks and a pound of feathers. If I have the same mass of both, right, a pound of each, well, it's not the same amount of both, right? But if I have a dozen of each, then that's the same amount. Even though a dozen would weigh differently for bricks and feathers, we know that a dozen means 12. So if I have a dozen of each one, I have the same amount of both. So with our different substances that we're going to be working with, comparing by mass doesn't necessarily work because, well, different things weigh differently. So we use the mole in order to level out and make everything even for us to actually compare their quantities. So what we're really trying to compare here are the number of particles present in a sample. Now, particles will fall into one of 4 categories, kind of depending on what the substance is. You can have particles that are atoms, molecules, formula units, and ions. So an atom is used to describe the particle of an element. So we would say, atoms of carbon. A molecule would represent the covalent compound particle. So if we have something like water, which is a covalent molecule, we would say we have molecules of water. Formula unit would describe an ionic compound, like salt, NaCl, sodium chloride. We wouldn't say we have molecules of salt. We would say we have formula units of salt. And then lastly, ions just represent your lone, free-flowing ions. So the particle type would actually depend on what the type of substance is. So this is the terminology thing, knowing that each one of these words represents a type of particle. So when we're using the mole, we are representing how many of, whatever specific type of particle we're working with here. So let's use some examples on how the mole is used. So now in our example, we're going to look at how many atoms of iron are present in 0.67 moles of iron. Okay, so we're actually going to set up a little chart here, and this chart I'm going to label, and it's going to help us do our conversions. So our chart's going to start off by taking what we're given. We're going to multiply by what we want and divide it by what we have already. So whenever we do unit conversions, like this mole conversion, this chart's really going to help us to get to what we want. So setting up in the context of this problem, I have, or rather I'm given, 6.7 moles of iron. I want atoms of iron. And we already have the unit of mole. So now, in this blank space I'm leaving here, we just have to figure out, well, how are atoms and moles related? Like we've just seen, 1 mole of anything, so in this case iron, would have 6.02 times 10 to the 23rd atoms. So then our math becomes 0.67 times 6.02 times 10 to the 23 divided by then 1. So when we work this out, we end up getting that 0.67 times 6.02 is 4.03 times 10 to the 23 atoms of iron. Okay, so that's how we approach mole conversions between moles and particles. In order to go from moles into particles, we are multiplying by Avogadro's number. Now let's look at the reverse case here. Okay, I want to calculate the number of moles present for hydrogen in 1.24 times 10 to the 24th molecules of hydrogen gas. So once again, we're going to set up our proportion, right? Our conversion chart. We are given here 1.24 times 10 to the 24. I'm just going to squeeze right in here the word molecules. This time we want moles, so moles is going to be on the top. And we are already beginning with molecules. Now once again, we're going to fill in, well, how are moles and molecules related to one another? Well, 1 mole of anything would have 6.02 times 10 to the 23. So going back to the fact, right, that atoms and molecules both fall under the particle category, we can use Avogadro's number in both these cases because they're both representing particles. So then, working this out, 1.24 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd gets us 2.05, or rather 2.06 moles of hydrogen gas, H2. So in this case, we ended up taking the particles we're given, 1.24 times 10 to the 24th molecules, and dividing it by Avogadro's number. So there you have it. That's how we convert between particles and moles. We're either multiplying by Avogadro's number in order to get the final quantity of particles, or we divide by Avogadro's number in order to take the given particles into moles.